This afternoon's lecture will be given by Dr. Victor de Boer. I want to steal a bit of his time to run through assignment 3 quickly. So I think in the morning session I already discussed the overall concept, right? But let's go through the assignment itself in detail, just to make sure it's completely clear what you should do. Right, so the overall idea is that you implement a server very much alike the server that you have used in assignment 1 and 2. But it can be more simpler because it needs to work only for one user, so you don't need to worry about keys and all these things that we had for the multiple user, multi-student server that we had. Okay. So the idea is that you run the server on your own machine, right? So once it runs on your own machine, it listens to a TCP IP port, in this case port 8080. And because you run it on your own machine, the domain name is not a real domain name, but it's localhost. That's the conventional brands nowadays. So if you type in your browser http://localhost:8080, right, your browser should contact the server running on your own machine. And what it needs to do, and that's the part you need to do, is that it provides a very similar functionality that we saw in assignment 1 and 2 on our server. So the first thing, it needs to get all the information from the database. So return in JSON all the smartphone information that is in the database. Right, that's step 1. And in addition to that, it needs to give the web developer that's using your API all the standard CRUD, create, retrieve, update, and delete interface options. Right, so it needs to be possible to add information to the database, to list one specific item instead of all items, because if you have a large database, right, every time returning everything becomes a bit clumsy. So you also want to be able to return a specific item to retrieve. You need to update an item. So if you make a typo and you only want to update the brand name, for example, without adding and deleting everything else, that should be possible. So an update, and you need to be able to remove a phone from your database. Right, so it's create, retrieve, update, and delete. And each of these services, right, needs to be available to web developers over an HTTP REST interface. So all the rules of thumb that I said in the morning lecture, right, that you can break if you want to. You should not break them in this assignment, because in this assignment you should show that you understand how they should work and implement your interface properly. Right, so you could remove the first item in your database, right? But that would not be REST. You delete a specific item. So if you delete the same item twice, the second time nothing happens, and then it's nicely idempotent as the REST specification tells you to do. Now, what is very important is that this service needs to be documented, right? And the documentation would have been very much the same as the documentation of our web services if we would have provided them to you, right? So every year I get a student, and this year there was an exception. Every year I get a student that asks me, why didn't you document your server? Well, the answer is we didn't document our server because the documentation of our server is the answer to assignment 3, right? So this missing documentation is the documentation you need to make here. And like I said in the morning session, I would start there. Start with the documentation. Start with writing down all the information you need as a web developer to use these services, right? Because the first thing you need to think about is, okay, for each service that you provide, for each of these 5 points, what is the URI for the resource? Right? What is the method? What is the format of the resource? Hint, JSON, right? What is the format of the resource? What is a good example JSON body that I want to have returned in the first item? What is a good example of a JSON object returned in the third item? Right? If you write this all down in your documentation, then the second step, actually implementing this in Python, is a lot easier. and there are a lot of points. Right, so for each of these 5 items, you need to pick the most appropriate HTTP method. So if we go back to the first one, retrieving all the information in your database, what is the most appropriate HTTP method? Get, right? And the last one, removing data from a specific, what is the most appropriate method? Anyone? Sorry? Reset is not, as for I know, not a HTTP method. So delete is a HTTP method, right? Okay, so you can do the other ones yourself. So every HTTP get that you do use, right, needs to be safe. Everything except for post needs to be idempotent. All responses, the body is JSON. If you send things to the server, right, the server should also accept JSON. So if you do the update and you send stuff, or you do the add item and you send stuff to your server, like you did in assignment 2, right now you should receive that information and put it in your database. And you also expect JSON. All responses need to have the appropriate HTTP headers. Right, so think about what headers you need to set, because not all headers are set by default. And all responses must deploy the most appropriate HTTP response codes. Right, so if something goes wrong, and think about what goes wrong, right? If you don't test for errors, then you can also just pretend that everything is all right all the time, and always return 200 even if something goes wrong. But that's not the intention. So think about what can go wrong. So that's the overall part. The documentation is already worth a lot of points. So again, start there because it makes the implementation easier, but it also can give you a lot of points. And with documentation, I mean the documentation like we saw in the Spotify and the Twitter examples in the morning. You also check them in the lab questions. I don't mean how to install the server on your machine, right? So don't write instructions with first install Python, then install bottle, and then run Python -server.py, something like that. No, that's the instructions for installing server. I want the instructions for the web developers that use your API. Right? So it should be in terms of use this resource, use this HTTP method, expect this format, that type of instructions of documentation. And installation instructions are also not necessary because if you use our example code, it will be the installation instructions will be the same for your code as for my code. So I know how to install them. You don't need to write instructions for that. Okay, so I'll skip the implementation part. I will go to the rubric. So if you show either in your implementation or in your documentation that you understand all the REST principles that we are asking you to do in this assignment, it's already worth 30 out of 100 points. If you also properly document that, you get another 20 points, right? So by just showing proper documentation and showing in the documentation that you understood all the REST things, you already have half the points that you can get in this assignment. So another reason to focus on documentation first. And if you also implement everything, you get 35 points out of 100 extra. And if you do it in a very nice way, you can get the remaining 15 points. And you get also as a bonus for if you make your assignment 2 work with your own server instead of our server. But that means you also need to implement all the client-side extras of this assignment. Right? So that is extra. But that's by only doing this half, right? Well, you're already going to get 100 points. Okay. So far the assignment. Are there questions about the assignment? Again, right, there are a lot of questions about this topic in the next lab session. Start there and then switch like halfway to the assignment. And the next is web science. Victor.
Thank you. All right. Okay, this should work. Just miss the mic. Okay, so good afternoon. So this is my last lecture for you. I'm sad as well. But it's about a really cool topic. So it's about web science. And I think it's quite important to talk to you about this today because so you're all doing web technology, and it might seem, and it actually is, quite a sort of technical baseline course, right? So you learn a lot of the basic stuff, how the web works and how you can build it. So it's like a practical course, and that's also the practicals itself are an important thing. But of course, this is university, and all the education is very closely related to research, right? So it's one of the things that sets it apart from other types of vocational education, for example. I just want to show you also today the type of science that goes on the web. So what kind of research do we do? I think both Jacco and I have called ourselves web scientists at some point, or might even do that sometimes still. So this is also for you to show that this is actually, it's not just a bunch of engineering stuff. There's actually also where we're thinking about this. And we're thinking about this in different ways, and we're not the only ones. That's what basically this lecture today is about, right? So we're still talking about the web, right? And if you look at this, you might not recognize it as being the web first. It might look like a constellation or stars or something. And that might trigger actually, oh, this is actually what astronomers do, right? So they look at the stars and they ask questions about it. So they look at it as a phenomenon. And this phenomenon started what we now know around 18 years ago. It was not a natural phenomenon. It was actually man-made. Not only by this man, but by people building technologies, and we have documentations that we can study to think about how the web works. And there's all kinds of graphs and pictures that show in some way that this is an important thing, right, with capital I, capital T. So the web is important. It's a thing that we all use, and it has some sort of impact on daily life. So in that sense, it's too important to be ignored, right? And that's basically what web science is about. And that's the claim of web science, is that this thing is something we need to understand. We need to know how it works, the way that it does, what happens on it, and how to study this. And then I think what for me is the interesting thing about the web and why I like to study it is because it's built on this set of protocols and these technologies that we're using and you're actually building. So you now have you understand the nitty-gritty details and you can build web technologies yourself. But what's interesting, thank you, is that it actually gives rise to very complex phenomena, right? So it's not the HTML that you see. It's people doing wonderful and horrible things on the web, and really interesting social effects turn up on the web, right? So from cat pages to we talked about cat pages a lot. So this is an interesting phenomenon that didn't exist before the web, or social networks, right? So the way that we interact with each other as humans, as biological beings, completely changed through the web, and that's all made possible through these set of fairly simple protocols and technologies. Right, so if we want to understand that, then we have to have some sort of new type of science which takes this sort of holistic, systems-oriented view on the web and its ecosystem, so not just the technical point, but also what people do on it. All right, and then acknowledges both these aspects, this multi-aspects. And this is what is called web science. Right, so this is a new type of science that we think makes sense to include in all these other types of science, like mathematics, studying of numbers and theorems and angles, and astronomy, the study of the stars and planets. Right? We think these things are important and we need to study. So this is what web science is about. Okay, so what is this web science then? So let's start at a website, for example, Wikipedia, to tell us what web science means. So they also recognize this sort of multi-angle, multidisciplinary view on web science. So they say web science is the study of, one, the social behavior on the web, right, at different levels, but also the technology that enables it. So this is again this interesting back and forth between technology and complex phenomena, right? And 3D explicitly how these interactions work. Again, so this is the interesting part. How can we get these complex things on these super simple technologies? So this is an image that is made by one of our colleagues, Stefan Stab. So he's interested in how this web is actually transformed and how the users interact with technology. So it's not just the technology, it's the way that users interact through different devices with this tool, the web, or the phenomenon, and how people actually produce and consume data, and what kind of questions we can ask. For example, we can ask questions about the data, about all kinds of protocols, about governance, right? So we talked about stuff like this, applications, etc. Right? So there's different views that basically say the same thing, that there's this complex interactions between high-level processes and low-level processes or technologies. Okay, so this is important that, and from a scientific point of view, you have more or less observational sciences. But I think what's super cool about web technology is that the web is not like, it's not like the stars and the planets, right? We can just study them, and then we can tell the world what they look like, right? Which is nice. But in the web, we can do one better, right? We can study it, and if there's something wrong with it, we can fix it, right? So this is the thing where engineering and this more observational study works like. So this is a bit in like in medicine, for example, right? Which are really the doctors of the web also. So it's both actionable as it's both observational as an engineering discipline. And that's what we've been doing. And I think you've seen examples also in some of the lectures that Jakob gave. We see that there's a protocol IP, and then it's not enough, so we have to build another layer on top of it, and then it's not enough because we want to do these other things, we build another layer on top of it. And I'm just going to show you one more layer also later on in these talks. Okay. So again, this notion of additionality, of this multi-angle, multidisciplinary idea of web science. And this is really what the early web science people have been hammering on about, is that web science is not just computer science on the web, right? It's not computer science where we focus on one thing. No, it actually needs other types of disciplines to also tell us things about how the web works, right? So it's not just things that happen on the web, but it's actually talking to people from other backgrounds, like economics and law and media studies, right? So what kind of things appear on the web? Political science. How do politics work, and how are they changed on the web? Is politics the same on the web, just on a different platform, or has politics fundamentally and forever been changed? We'll show some examples later on. Also mathematics, like what are the mathematics of the web? How does it look like from a statistical point of view, or from a network point of view? Biology, right? So does the web mimic things from biology that we already know? So this picture acknowledges that it's at the center of the collision of all kinds of different disciplines, and a good web scientist is aware that it actually is not just one discipline again. Okay. So web science, I think one of the earliest articles that mention this is this article by Schneiderman. I believe you have seen it. Right, so this is sort of a provocational position paper that says we need to have these websites, right? Basically just points that I've been making now. Computer science alone just doesn't cut it. It's not just mathematics. It's not just sociology on the web. We need to have some sort of getting together of people and talking to each other to be able to understand this thing that we have. Right? And as he says, well, we have to, from a computer science perspective, we have to go from studying chips, right? So from studying the computer technologies and the protocols and the technologies, to moving to clicks, what people actually do, what have they been doing on the web, right? Because it's a combination of technology and human behavior. So this was 2007, and roughly 10 years later, sort of the 10th anniversary of web science. So this was 2 years ago. So there's a Web Science Trust, which was started in 2006, and at its celebration in 2010. Right, so it's basically a recognition that this makes sense. Also, not just from academic perspective, but actually from people, well, owning the web is a big word, but let's say very important companies on the web, like Eric Schmidt, the CEO of Google. So there's all kinds of interesting quotes that you can read here about how important the Web Science is. And what's really cool is that this year, the Web Science Conference is going to be here. So it's going to be organized by VU. So this is the Web Science Conference in the world, with many important speakers, and you can actually get tickets for this, and we might even have discount tickets for students, I'm not sure. And what's super cool is that this guy is going to speak. Now, he might be a bit small to see in the back, but I'm sure that you by now recognize this man even from very far away. So this is Tim Berners-Lee. He actually will be speaking here, and he will actually give his what's called address for receiving the Turing Award, which he received last year. Right, so if you look at this website, so this is website18.org, you can actually see the types of things that these people are interested in. And you see, if you look closely, you browse the website, you see that they're not just addressing computer scientists, but also sociologists and anthropologians and all kinds of people. Okay, so this is sort of the community, which is nice, but now we want to talk a bit about actual web science questions, right? The type of things you can study when you study the web. Right, and one thing is to really look at it as an objective study. So what is the web? What does it look like? What form does it have? Right, so that's the next part. Right, so what does the web look like? So this is a sort of a mathematical computer science perspective on the form of the web. Right? We can do the same with planets or the solar system. We can draw pictures, but how do we draw a picture of the web? And what does it even mean? Okay, so one way of looking at the web is looking at the web as a mathematical graph and thinking about the mathematical properties of that graph. So, what does the web look like? So one thing that we've seen a lot, and I think you might have seen this also in introductory lectures, for example. But one very interesting thing is that the web takes on a specific form of network. There are all kinds of different networks, and you have networks in which nodes connect randomly to other nodes, which end up being these type of exponential networks. Right? So they are a big sort of homogeneous mess of links. And we know actually that the web, our web, like the worldwide one, doesn't look like that. No, it looks like this. And this is what is called a scale-free network. And every measurement done on the web shows that it's actually like this. So what is a scale-free network? It's actually a network where you have highly connected nodes, these so-called hubs, and you have less connected nodes. And actually, this is sort of a repeating form. So there's both on a high scale, on a large scale and a low scale, you see this sort of repeating thing. But we'll talk about it. Right? And these hubs are actually known sites. So this is Wikipedia and Facebook and YouTube, these things that you also know about. Right, so this picture I showed in the search lecture. So this is a phenomenon that we have observed. This is not a mathematical nature of all networks. This is the web. This is how the web works, and we have some ideas on how it got to be like this, and I'll tell you about this in the next slide. Right, so this is basically the same thing. So you have a lot of these hub nodes that sort of connect, are sort of funnels of connecting links to other pages. Right, another way of showing it is this. So this is an actual picture of a distribution of in-links and a number of pages. So this is in the green, the number of links that are incoming to pages. And then this is the number of pages that have this amount, right? So you can see that there's a very high number of pages with very few links, right? So this is the obscure cat page. And then there's very few pages with lots of links, right? So these are the hubs. And actually, if you draw a line, and you see that this is on a logarithmic paper, so this is an exponential distribution. And this distribution is the same or similar to the zip distribution that we also saw in language, right? So we find that there are some things in nature that compel us to make structures that have this. And one of these phenomena is what's called preferential attachments, right? So in the web, you can imagine that if I make a page and I want to make one link, so where am I going to link to? So some random page from some guy somewhere, or am I going to make my link to a page that I know about and might actually be used by other people? And so probably the latter, which is why one of the reasons, not the only reason, one of the reasons why there are very few pages with a lot of incoming, a lot of links, and very many pages with few links. And you can imagine that something similar happens in language, right? So when I use words that I'm sure that other people will understand very frequently, and I use words that are very hard to understand, hopefully not that much, right? So these are social things that sort of have their mathematical result in these kind of graphs. Right, so this is interesting that it follows the same distribution. Okay, so another example is this one. So this is another phenomenon on the web. It's very much related to this notion of scale-free networks. So who knows who this guy is?
Kevin Bacon.
Thank you. There are lots of Kevin Bacon enthusiasts. So this is Kevin Bacon, and he is considered to be the center of Hollywood. So does anybody know why? So maybe one of the Kevin Bacon fans?
Footloose.
Sorry?
Footloose.
Footloose, yes.
Well, there's the game, was it 7 Weeks of Kevin Bacon or something?
Yeah, so it's sort of 7 degrees of separation. This one called the Kevin Bacon game. Let me see if this link's still working. Yes.
It was in a lot of bad movies.
Oh, sorry. I need to. Let me turn up the volume. So this is Barbara Streisand.
Entertainer presents 6 Degrees of Kevin Bacon, our target. Barbara Streisand. Now, using movies that are currently showing on Entertainer, let's link Barbara with Kevin Bacon. Okay, Barbara Streisand was in A Star is Born with Gary Busey. It's your move, this is on you. Who was in Lethal Weapon with Danny Glover? Danny Glover was in Silverado with Kevin Kline. This is the good stuff. Who was in 6 Degrees of Kevin Bacon, our target. Barbara Streisand. Now, using movies that are currently showing on Entertainer, let's link Barbara with Kevin Bacon. Okay, Barbara Streisand was in A Star is Born with Gary Busey. It's your move, this is on you. Who was in Lethal Weapon with Danny Glover? Danny Glover was in Silverado with Kevin Kline. This is the good stuff. Who was in Dave with Kevin Dunn? You can't kill the president. And Kevin Dunn was in Stir of Echoes with, you guessed it, Kevin Bacon.
Whatever door you open in my brain, I want you to shut it.
What's more, all of these films are on Entertainer right now. So check it.
Right, so this is a game, 6 Degrees of Kevin Bacon. And the idea is that Kevin Bacon is the center of the whole universe, and everybody is super closely connected to Kevin Bacon, right? And here they make a quite elaborate path, but it's actually very hard to find any actor with the Kevin Bacon number, so the number of steps, that is higher than 4. Right? So most actors have acted with some other actor that has acted with Kevin Bacon, even if you take very obscure Dutch actors and actresses, for example. Right, so this is the idea that even though there are lots and lots and lots and lots of actors and actresses, because of their sort of the fact that they connect through highly paid and often appearing actors, they are actually really closely connected. And this is called the small world phenomenon. And it's been observed earlier in the 60s, where people said, okay, how far am I away from some random guy somewhere in the Arctic Circle, right? And if you think about who I've shaken hands with, right, I've shaken hands with Jacco, who's shaken hands with the dean, who shook hands with the dean of some university in the US, and that guy might have shook hands with someone in the Arctic Circle, and that guy probably has shook hands with some guy that shook hands with the Arctic Circle, which makes the connection between me and this random guy 7. Right? Let's take a note. And that number is actually remarkably low for the fact that we have this amount of 7 billion people in the world. Right, so this is the idea of the small world. Because of these hubs, because of the scale-free nature of these networks, people and pages and actors are really close together, closer than you might think. And this is a phenomenon that has been observed in lots of different types of networks that all have the same characteristics. Right, so if you look at, so you have what we call the diameter of a network. right? So which is the average length of the shortest path between two nodes in the case of the web pages. And actually on the web, right, on the whole of the World Wide Web with all its 50 billion Google index pages or whatnot, the average shortest length between two random pages is 19 links, right? So that means you can hop through, just through hyperlinks in 19 pages from any one page to any one other page, on average. Right, so where the average, I think the average distance between two people is 6, if I'm correct, so this is 6 degrees. And for Kevin Bacon, and for actors, it's actually around 3, and for the web, it's 19. So this tells us something about the shape and the form of the network. In that sense, we can use these mathematical formulas to study how the web looks and how it compares to other networks. Right, another network is this. This is my Facebook network from a few years ago. So unfortunately, the tool that allows you to do this is no longer up and running because of privacy issues, right? So sometimes there's a couple of different concerns on the web that cancel each other out. But I'm happy to show you all my friends and colleagues. And you can actually do mathematics on the network and make calculations about how close my different friends are related to each other and to other friends. And you can use that to visualize these kinds of networks, right? So this is a visualization purely based on the number of links between, right, friend links between my Facebook friends. And actually, that yields very meaningful blobs, right? So on the top right, for example, is a blob that is a VU blob, right? So these are VU colleagues. And then here in the orange one are my UVA colleagues, because I used to work at the other university. And you can see that actually they're quite close together and overlap a lot, because there's a lot of people that frequent both universities. And then you see like friends from my hometown, and you see family, and you see some other people, right? So these turn out to be meaningful clusters to me, social clusters that are purely based on mathematical measurements on, in this case, my personal social network. And again, these personal social networks take also the form of these scale-free networks, where you have a few these hypersocial people that link to a lot of people. Right. So that might be interesting, but there's also might be very profound psychological effects of this, right? So there's been research, for example, that shows that mathematically you always have less friends than your friends. Right? So it sounds depressing and might be depressing, but it's just a mathematical fact. It's not about you. Right? So your Facebook friends have on average more friends than you. And you can just calculate how that will work in a network, in any network. Right, so some of these things actually you might imagine have some psychological effects. So we know that the way that people react to Facebook posts can have some real world psychological damage. Right, so again, mathematics, networks, the web, the way people use the web are all intertwined here. Where's my mouse? Yes. Right, so this is an important realization that it's not a mathematical, it's not a, let's say, a law of nature that the web looks the way it looks. It's actually a form that emerges from the way that people use it. Right? So it's the way that people use these technologies. Okay, so let's start a little bit of a closer look to some other things that happen on the web, so to see where these different areas of science might interfere. Right, so this is where web meets society. So, for example, where web meets business. So the question is, how has business or economy changed with the web? Right. So there's a whole study programs that look on this, and the people that are interested in business information systems here, they will come to understand, if they don't understand already, that the way that people do business has completely changed with the web. Right. So I don't think there are any businesses in the Netherlands that do not have a website or do some interaction with the web. But how has it actually changed business models? Well, so this is, for example, the way that the music industry was changed. So before the web, it used to be that the goal of the big record companies was to find the next Michael Jackson and the next Madonna, right? And that's what they tried to do. They breed a whole bunch of artists, and they hope to find the one that catches on, because then you can print millions of records and sell them, right? Because printing costs a lot of money. You want to make sure that your bet is right. You can be off a couple of times, but not too often. Right? But you want to hit those these Madonna and Michael Jackson type people. So after the web, we still have the Michael Jacksons and Madonna because they still make a lot of money, right? So they're now called Lady Gaga or whatever your kids listen to. But it's changed because we now have this long tail. So what happens is that we don't have to print records anymore. We can just put the stuff on iTunes. It doesn't cost us anything, right? Disk space is cheap, and people are happy to pay for the bandwidth here. So what happens is that this long tail, right? So this is the popularity music sales. So here's this is an old one, Justin Timberlake, Madonna. There's Tom Petty. And then here's like the fairly popular band, so maybe it's like the Dutch, like a popular Dutch band. So you know they might have made some money, but not too much. But now suddenly in the world of the web, this becomes a you don't have to spend a lot of money as a record company, but you can still sell a lot of records, right? Then we have here the really long tail, right? Not a popular band or your roommate's band. And in the old days, these guys would never get their records printed because it would just cost too much money and they will never earn it back. But now it just doesn't cost anything to put your stuff on iTunes. Right? And actually this long tail is where all the money is. There's still money here, so we didn't stop doing this. But actually the volume of sales in the tail is often larger than in this part. Right? So that completely changes around the way that these music distribution platforms earn their money from the old days. Alright, so this is another, I was like this story, I never can find it, but I'm sure that it's true. And if it's not true, then the essence is true. So this is a guy from the UK who used to collect dinky toys. So these are these 1950s cars, right? And they're super cool. And he has all these cars. But then apparently the axles of the wheels, right? So the roll thing between the wheels, it was not very sturdy, so they used to break down a lot, right? So the brake. And then this guy, he found out a way to make these axles, right? So these tiny pieces of metal, and he did it in his backyard. And I think he was working at the postal office in the UK. And then so the web came along, and he was emailing with fellow Dinky Toys collectors, and they said, "Oh, could you send me one over the mail?" He said, "Sure." And after 3 times, he said, "Okay, I might charge something." Right? So now, because he set up a website, and there's a community of Dinky Toys collectors that he could address directly, he actually made enough money that he could stop his being a postman, and he's now, I hope that he's still a professional Dinky Toys axle maker. Right? And there's probably room for one in the world, but there wasn't room for one in the world without the web, right? Because you could never reach your customers. So suddenly the world is getting super small. This means something for which businesses might be viable and which not. Right? So these are 2 ways in which the web has completely changed around existing business models and how we think about business models. Right? So this is the way that most businesses do work now on the web, and that also matters for the small business guys. All right. So another example from business, we jump to politics. So I hope you still remember this guy. So. Right, so before the web, politics was basically you voted what your parents voted. That's a big chart, of course, but let's say it was very much, the web has really changed the way politics were done. And the first election where that really made a difference, I think everybody agrees that it was in 2008, in which, well, I think people working on Obama's campaign also claimed that it was a really big part of their strategy to really make sure that they use the web in all its forms and use all the social networks to make sure that he got the win. Right? So I think the way that U.S. politics is funded, if you do individual donations, you can only do small donations, right? Sub $100. So that means that you need to get a lot of people if you want to get a lot of money. Right? And how do you get a lot of people? You approach them through Facebook. And what they also did is they were able to mobilize people. So what happened a lot is when they were in there were these debates, right? And it was about as nasty as the previous elections. And every time that a Republican would say something very nasty about Obama, so they were measuring this in psychological experiments, it turned out that people, Democrats, would be very actionable, right? They would rise up and they want to do something and they want to stop the injustice. But you can never do anything, right? You're just one guy. You're sitting in your living room, and what you have to do. But then I said, we have the web, so we can actually, people are behind the device with which they can actually change other people's opinions. So they made all kinds of apps, right? And every time when there was a spike in outrage due to some television debate, people with these applications, they would get a notification saying, do you want to do something? Okay, then just text these 5 numbers and tell them that you are convinced that Obama is the next candidate. Right? They did all these things of measuring and then mobilizing people through the web and making sure that they would actually call other people and connect through them through all kinds of platforms. Right? And so the people that are behind the social media campaigns, they really claim that they were the ones that won the elections. And actually, if you look at our current US President, Donald Trump, his social media campaign was also super strong, right? Arguably stronger than his opponents. So if you look at how they actually do this, you can have a look at this Wired article. So one trick, I'll tell you, is one trick that they did is they can actually, so this is what Facebook does now, right? Anytime you all guys are on Facebook, you're actually looking at 50 different versions of Facebook. Because Facebook constantly changes its layout and tests whether you like it or not, right? By the way you click or do something. It's called A/B tests. And the people from Trump, they were running at the highest point. They were running 175,000 variations of specific ads and measuring how people would react to it, right? Whether they would click on something or not, or whether they would click away. So they were doing this sort of constant high-speed updating of their advertisement campaigns. And without the web, this would have never been possible, right? So you would do one super vicious attack ad, put it on the television, and hope that it would work, and then maybe 2 weeks later you can make another one. Right? So now we have 175,000 consecutive ads. Right? So politics has changed. I think everybody agrees. Without social media, no more politics. Right? Remember, you probably don't remember, our 2 prime ministers ago, Kok, he was famously filmed while someone was teaching him how to work with a mouse, and he had no idea what's going up with the mouse was, so he tried to pick it up like this, right? So I'm pretty sure that no prime minister will ever be elected in the Netherlands who is not at least somewhat web proficient. So one more, and then we'll break. So journalism is very much, I think, closely related to this thing. So journalism has, of course, changed a lot, and I think journalism itself doesn't really understand how we're doing, right? So fake news and fact-checking, all these things are very much in flux. So that's also a problem of web science. That's very much a moving target, right? So the way that in which facts get copied and facts between quotes is something that's really hard to grasp. There used to be newspapers and a whole redactional process behind the news. And now it's websites upon websites, and it's very hard to trace where information comes from. And that's one of the things that we are also been working on, is to identify, if you find a fact somewhere, can you actually trace it back to an original source? Or can you trace it back far enough that you can maybe identify whether or not it's a trustworthy source? And what does trustworthy even mean? Right? So these are questions that we as scientists also try to come up with answers for, because this is a real world problem, one that you really know. Right? And this also has something to do with the democratization of journalism. It used to be the journalist who is high and mighty, the fifth power, really sort of a class unto itself, which could determine this is the truth and this is not the truth, and we will play by our own rules. And now we have everybody's a journalist, right? Facebook and Twitter and what's it called, Periscope, everybody's broadcasting live. So that means that information comes from so many different angles, and the barrier between producer and consumer of news completely is gone. And responses come not just from science, of course, but also from the web itself, right? Fact check sites and people providing balanced views on these running issues. Okay, so after break, I'll jump through a few more, and then we'll go into detail on 3 issues that we've been working on lately to give you more background on what we at Q are also doing. Okay, see you in 15 minutes.